Okay, let's take a look at this 16th Feb problem. It's a LeetCode daily question, medium one. Construct the lexicographically largest valid sequence. So we are given an integer n. We have to find a sequence of elements in range 1 to n that will satisfy all these conditions. Integer 1 will occur only once. So we can't repeat the integer 1. For our integers 2 to n, we can repeat them once. So they will only appear twice in our sequence. So also those integer that we are repeating once, they will have distance between their same integer. Like if the integer is 2, then the space between those two repeated integers will be 2. Like there will be two other numbers in that between those two. Okay, so the distance between two numbers on sequence ai and AFJ is the possible absolute difference of the indices j minus 1. We'll get the number also because of this condition. So we'll return the largest lexicographical sequence. Granted that under the given constraint, that is always a solution. Okay. A sequence A is lexicographically larger than a sequence B of same length if in the first position where A and B differ, sequence A has a number greater than the corresponding number in B. Okay, so in case we get more than one solution, so this is how we'll return a correct sequence basically. So a number has greater uh, sequence A will have a number greater than the corresponding number in B. So this is how we will check the condition. For example, 0, 1, and this array is lexicographic larger than the 0, 1, 5, 6 array because first position they differ is at number third. Okay, so these two arrays have same 0 and 1 number integer. In the third integer they are different, so we'll take the first one because 9 is greater than 5. This is how we'll check this condition also. Okay, so in the constraints we have 1 to 20 only.
Now we'll start with our first example. We were given input n is 5. So firstly we'll consider how many numbers will be in our sequence. So we can use n into 2 minus 1, that is 9 numbers we will get in our sequence. 1, 2, 3, 4, 6, 7, 8. Why did we use this formula here? Because we know that only 1 will occur once and all other number will occur twice. So we subtracted minus 1. Along with this, we will also make a boolean array here. This is the indices of our array. We will put false firstly. Basically we will take one number at a time and then we'll mark these as true once we assign them in our sequence array. Okay, so we'll mark indexes here 0, 1, 2, 3, 4, 5, 6, 7 and 8. We'll write 5, 4, 3, 2 and 1. Okay, n was 5, right? Let's put 0 here first in this. Now we check if we can put 5 in our 0 index. So we can do that. Okay, so we put 5 here. Now we have to also put 5 here on our 5th index, right? Because 5 will have to be repeated. Now we'll check for our 4 here. We'll mark this as true because we have used our 5 number. Now we check if we can put 4 here. 4 plus 1 will be 5, no? But on our 5th index we already have our number 5, so we can't put 4 here. Then we skip 4 and go to our 3 integer. and check if we can put 3 here. 3 plus 1 is 4. Okay, so 1 and 4 index. So yeah, we can put 3 here on first and fourth. Okay, so we put 3 here. So we put this as true again. Then we go to our second integer. So now we check if we can put 2 here. No, we can't put 2 here because on our fourth index already there is 3. So we'll skip this and then we'll check for R1 if we can put 1 here. So we see that 1 can only occur once. So it is possible to put 1 here. Okay, so we put 1 here. Okay, so we'll mark this as true as well. Again we'll backtrack to R5. Now we check for our 5. 5 is false or true already. So we again go to our 4 number. 4 is also 4 is not true. So we can use 4 here. Okay. So now we check if we can put 4 here. 2 plus 4 is 6. Okay. So 2 and 6. So now we check if we can put 4 on our second and sixth index. So yeah, we can put 4 here. So we put 4 here. Okay, like this. So we mark 4 as also as true. Now we check for as 3. 3 is already true. So we'll skip this. Then we'll check for our 2 number. So 2 will have 7 and 9. We don't have any 9 index here. So 2 will not be put will not be here. Okay, then we'll check if we can put 1 here. Yeah, 1 is already true. So we'll again complete the cycle again. Okay, now we'll put all the numbers that we have put in the sequence array here. So we have already put 5, 3, 4, 1 and 2 we were not able to put properly. Okay, so now we'll backtrack from 2 to 1 again. Basically we'll empty our third index number. We'll backtrack. Okay, so we'll empty our third index. Again it will be defaulted to 0. Now we'll check. So we already put 5, 3, 4. Okay, 1 we have already tried but it is not correct. So we have 2 left. So we'll try to put 2 here. So can we put 2 here? 2 plus 3 is 5. So we have we put 2 here? No, we can't, because at our fifth index already there is a number 5. So 2 will not be put here. Now we again backtrack to our 4 number. So our fourth number is at index 2 and 4. So again we'll empty these numbers also. Okay. Again this will be defaulted to 0. Now we try to put. So we have number already used. We can define it as again false. 4 is also now false. Okay, now we already have 5 and 3 used. So we have left 4, 2 and 1. Now we'll try to put 4 at index 2. Can we put 4 here? Actually we can, because 4 plus 2 is 6. So at 4, now we check if we can put 1 at index 2. Yes, we can. So we put 1 here. So we'll convert this as true. Okay, now we move to our index 3, because all other numbers except 2 has already been used. We can't put 2 here because 2 plus 3 is 5, and at 5 index we already have 5. So we try to put 4 here. So can we put 4 here? Yes, we can. So our number will be at index 3 and 7, right? So we will put 4 here. Okay. Marked 4 also is true. We have only 2 left. So can we put 2 here at 6th and 8th index? Yes, we can. So we'll put 2 here at last. Now we move to our ninth index. It is as already all numbers have been used. So this will stop our operation and will output this array, that is 5, 3, 1, 4, 3, 5, 2 and 4, 2.
Now we'll start with the code part. Firstly, we'll define our booleans. Boolean used and sequence basically. New boolean and plus one. New, and again we'll define our sequence here array. Here we will 2 plus n minus 1, that formula of getting the number of sequences of a number. We'll backtrack. Define here 0 are used sequence and n. Okay, integer that would be code in our input. We'll return a sequence here. We'll make a new function for our backtrack basically. Boolean backtrack. Again we'll define our index here. Int index use boolean and our sequence, our integer n. Then we'll start a while loop. Here index less than sequence dot length. So then we'll return this as true. Return true. If index is sequence dot length, x dot length, no, we'll give this condition is equals to sequence dot length. Also with this condition also, sequence is not equal to 0 for index equal to 0 and index 0. So index plus plus. Then for loop y is equals to n and will I is greater than 1 and I is minus. Okay. Used used of I will just continue. I is equals to 1 and what will do we'll define sequence as by index as one, as I, and use as true. I as true. Backtrack index plus one used, and other one was sequence as sequence. And will again return this as true. No sequence. If 0 used I be considered false. This condition is defined. Now we'll start with our else condition. Else if index plus one, so and index plus one is to 0, and we will do sequence I times index plus one I, no? One used I e to track track index plus one used sequence and I and n will return again. It's true. Mm, mm, Same as above, index 0 and use I false. Sorry. Here we have to sequence sequence index plus one. Now just return says false, and now we'll try to run it. think we should convert our boolean to int here of a sequence. So int, so there. Now try to run it. Auto bound. Right. So here also we should put in I. Now it should work fine as well. Now we can submit it. That's all. Thanks.